The objective is still to solve an exponential equation. I have a couple of different forms today. Here is the first one. You have 6 to the x plus 1 power and 3 to the 2x minus 1 power. Changing base on this would be rather difficult, so we're going to try it this way. We're going to use a log of both sides. So log of 6 to the x plus 1 power equals log of 3 to the 2x minus 1 power. You can't foul up that first step. From there, you're going to move the exponents out to the left of the log in parentheses. So it'd be the quantity of x plus 1, close the quantity, times log 6, and set that equal to the quantity of 2x minus 1, close the quantity, times log 3. Now distribute in each case. You have to multiply x times log 6 and 1 times log 6. You will come up with x log 6 plus log 6. And on the right side you'll have 2x log 3 minus log 3. What you have to do next is get your x's on the left and your other stuff on the right. No different than a basic equation. This has got to stay on the left, x log 6. On the right hand side, 2x log 3's got to go over with it. Crosses the equal sign, so change the sign. On the right we had this staying where it's at. So negative log 3, and then from the left plus log 6 has to move over and become minus log 6. On the left hand side you have two x terms, but you need to factor out the x term from each of them. If you take an x out of both of those on the left, you're left with log 6 minus 2 log, strange looking L, 3. And then of course the right side stays the same. Again, we took an x out here and here and just put it here, 1x, and multiplied it by the quantity of log 6 minus 2 log 3. We just took the x out of both of them, factored it out. Now it's a matter of simple division, even though it doesn't look like it. But on the right side, negative log 3 minus log 6, and that's over log 6 minus 2 log 3. The answer to this problem is 7.13, rounded to the hundredths place. Here's another example, and if you want to solve for x, you must move constants away from the side that it's on. That's just a regular 81. So 9 to the 2x plus 1 power equals 162 minus 81. And of course 162 minus 81 is going to be 81. Now in this case you could change the base because you have a 9 and an 81. That's pretty simple to work with. Or you could use the log of both sides like we did before. Since we already did the log of both sides in the last example, I'll change the base here. What's another way of writing 81 as a power of 9? 9 squared, yeah. So you could have 9 to the 2x plus 1 power equals 9 squared. And if your base is the same, in this case it is, it's 9, you can get rid of that and just set 2x plus 1 equal to 2 and solve that simple equation. Move the 1 to the right, change the sign, simplify. And if you divide 1 by 2, you'll come up with a decimal of 0.5. On this practice problem, you're going to need log of 7 to the x plus 3 power equals log 3 to the 3x minus 1 power. Move the exponents out to the left, like this, and like this. Next up, you're going to have to distribute. You would get x log 7 plus 3 log 7 equals 3x log 3 minus log 3. You are not multiplying 3 times 7 to get 21 anywhere. This is just one term. Think of this as a variable, x. Alright, we need our x terms on the left. This one is already there, but that's got to go with it. So x log 7 minus 3x log 3 equals negative log 3 minus 3 log 7. Factor out an x. So x times the quantity log 7 minus 3 log 3. Close the quantity equals your right side. Now to get the x by itself, you have to divide this by this. Make sure you put parentheses where they are needed. Okay, on this problem we're going to leave 4 to the 4x minus 3 where it's at and move the 144 to the right, change the sign. Simplify on the right to get 256, and if you remember, 256 is a power of 4. So if you want to change the base, you can make the right side 4 to the 4th power. By doing that, since we have the same base, you can cancel those out and have 4x minus 3 equals 4. Move the 3 to the right and add it, and then divide 7 by 4. Remember, your answers have to be decimals, and that comes out to be 1.75.